Hey everyone, in this video we will talk about designing and simulating counter circuit in Verilog. Sequential circuits. So our design is a sequential circuit. The counter circuit is a sequential circuit. So it has all the properties that sequential circuit has. It has a memory element and combinational part. The memory element is just to save the values that we need. The combinational part is just used to decide what to store. And decision box, it's a decision box. It depends on the memory element that's coming and the inputs that's coming from outside world. And the basics of counters in Verilog, when we design, we have to keep in mind that we have two parts: the sequential part, which is the memory element here, and we have the combinational part that does the increment based on the inputs that's coming into the combinational part. So clocks, as you know, they are used to control the memory elements. The memory elements that could be thought as flip-flops, they could be thought as switches. They are closed whenever a certain type of value of clock comes. In our case, it's called a posage, which is a rising from 0 to 1. That's called a posage. So all the values has to be ready from the combinational part just before the rising happens. So when the rising happens, the values are saved and they are passing into the other side of the memory. So this is the posage. Same thing happens to the next line. So until this time, a new value is produced, increment, this value plus 1 is given here, and when the close rises, it will pass to the other side, which is to be saved. It will pass to be saved. Same thing happens. So same thing happens. It's saved in this way. So this is how a counter works. Basically, this is how it works. But we can see there's a problem here. What is the problem? That this system, when it's running, no one could control it from outside. So there is no interface. They cannot connect, and you cannot control what to do. So this is running. So this will run forever. You cannot control it from outside. Okay, there's something missing here. The thing that's missing is that it's a button. A button is missing here. That button will be used to control the decisions here. The decisions that are made here, it controls using by button. So this is a combinational part. So this part is the combinational part here. This part is what is done here. Okay, and the star stands for sensitivity list. So in this case, we have button and count values are the sensitivity list. They could have put them in here, but putting a star is enough. All the sensitivity lists in here. Okay, so the other part is the sequential part. The sequential part has count and count next. So count next is saved into count. This is triggered by clock, a posage clock. So we have two always blocks. The one is always posage clock and the other is always at start block. Okay, and what is actually happening here? Let's see in the next slide. So what's happening here is this part, which is the combinational part, is dependent on button. So if button is 1, then do increment. Count plus 1 will give you count next. So count next is equals to count plus 1. What about the other time? When button is 0, just save count again. Okay, so that's what's happening here. As you can see, there's a thing that's called default. So this default value is given here because we don't want any latch. Latches are sequential circuits that doesn't have clock, so they are not dependent on clock. So we want our circuit to be dependent in clock. So we want to know when things are happening. So that's why we don't need any latches. So for that, we have to at least give any value to count next. Count next has to get a new value. It could be old value. It could be old value, just like we are doing here, or it could be any new value, but it has to get some value in case some of the conditions are not satisfied. So we have this, we give this value, the worst case. If things go well, then count next will get a new value here. Okay, otherwise it will keep whatever is happening here. Okay, this is the worst case. This is like a lifesaver kind of stuff. Okay, this is just a worst case, you have it here. But so if in the best case, then it will get a new value, so there's no problem. So I have it here, but I can overwrite it here when this condition is satisfied. So as you can see, this part you can delete it, because when button is 1, do increment, otherwise just keep whatever it is. So this will be enough, and you can delete this part. Okay, because this is a good habit of writing. Just write the worst case at the top of the always at start block and forget about the other cases. Just think about the positive cases and you can do it. So this line is very important. I have written it in code also, okay, in the source code. So this is just an example. So in our lab we will do something a little bit different from this, a little bit. So here in our lab, this is LAB6 counter, up down counter. So it will increase and it will decrease. That's the main difference here. The main difference is it will increase and decrease. Okay, so based on the up down value, this is like a switch, just like you turn on light in the house, just like that. When you press it to 1, it will increase. The other time when you don't press it, when it is at 0, it will decrease. Okay, so number next will get a new value of number -1 or number +1 based on whatever up down is. So you have to check for up down value. If up down is 1, then number 1, number +1 is equals to number next. In the other case, it will be minus. Okay, so this is what's happening. So this slide will help you to understand how things work. Okay, especially this part will help you how to do it, but this is only for plus, so you have to do for minus also. So that's why I have explained things in here. And the other additional thing in our lab is that it has, so this is the circuit that we have. Our counter is just counting and giving values, so that value is given to our segment driver. So it could be 1, it could be 2, 3, 4, 5 until 15. Those values are displayed in our 7 segment. So we have done it earlier in previous labs, but this time you will be expanding that from 0 to 15, considering that 15 is F, 14 is E, A, B, C, D until F, from 10 to 15 because it's hexadecimal. So you can display such values. So these are just independent. Okay, this is one independent part, which is it depends on clock. This is another combinational part, and we have another combinational part here. So in total we have 3 always blocks. Okay, this is always at start, this is always at start, and this is always at pause age in our designs. Okay, so now let's go to ISE software and add our project and show you and explain a little bit about the code that I have provided already. So let's create a new project. That project has to be inside any folder that you need. Be careful, the path should not have any Turkish characters. Some students have had such problems. Okay, let's save it. Same way as you might remember it, just continue in that way and add and copy the values. For me, I have put it in the desktop, but sometimes you could have it in different ways. So I just add these 2 files and then okay. So inside here, don't forget this one, it has to be set into resource properties and say all simulation apply. And now you don't see it here when we are under implementation, but if you go to simulation, you'll see it. You'll see it here. Okay, and let's go back to implementation and let's look into our code. So in our code, these are just all same thing. I'm not going to explain this because this is very normal. So we have registers here, our flip-flops are here. So we have internal register, which is called number and number next. These are our flip-flops, our registers. These are the ones that are saving. So number next is produced from this combinational part, and we are saving it whenever clock is coming here. The other part is combinational part 1. So combinational part 1, it has given its default value. In the worst case, when all of these conditions are not satisfied, at least I will save the old value that I have in the memory. I will save it. I will save it again so that I will not lose it. If I don't save it, then number next will get some value from somewhere and it will destroy my memory. It will change the value that I have in the memory. Reset, you know it, any values number next has to be set in 0. Otherwise, I will do my job. What is my job? This is the part I'm doing. Fill in here, this is the part you are filling. And you will check if up down is 1. If up down is 1, then you do increment. Number next will get a new value. Number plus 1 will get some value here. And up down is 0. If up down is 0, then you will do decrement. So these are like the ones you are doing. Okay, this is the part that you are doing. And if you don't understand here, you have to go back to my explanation on this slide. And just if you go back 5 minutes through the video, you'll understand it. And the other part of the lab is, which is called always at start, another 7-segment combinational part, another circuit. And so we have default, all of them are 0 0, all of them are off. As you know, it's anode, so all of them are 1 1 here, except this default value is given here. When resetting, you have to give all of them to be off. When you make them 1 1, all of them are off. So you will fill in here. So this part is filled already, just to show you how it's done. And for 0, for 5, it's done, and you'll continue doing to the rest of this until E. F is also done here. You have to fill this part by yourself. And remember that it's hexadecimal. Hexadecimal, as you know, we can count from 0 to 15. It's 4 bits. And until 9, everything is okay. But after that, 10 is A, B, C, D, E, and F. It continues like that. So respectively, 10 is A, 11 is B. It continues like that. So this is what you're doing. So after everything is okay, what you will do is you'll go to simulation and you will run this part. Okay. When you fill it, you have to run it in this way, and then you click on default WG, and one thing you should do not forget it, go here, click here and add number here and relaunch. There's no need to save. Relaunch and go back to default values and press this. You can use these buttons to make sure that everything is okay. And another thing important is convert this one into decimal. Radix hexadecimal. If you make hexadecimal, then you can see this. So how do we check that everything is okay? So number is what we look for, and another thing is seg. So to see seg, it looks short, you just press plus and you'll see what is going on here. Okay, but for now let me make it small so that I'll look at number. So in the beginning I have 0, after reset value I have 0. So when up down is 1, because my test bench is doing everything. My test bench is doing everything here. So in my test bench, what I'm doing is I give 1 1 1 1 for 6 cycles. So that time my design has to increase, yeah, 0 1 2 3, it's increasing. When up down is set to 0, then it starts decreasing. As you can see, it starts decreasing. Now it was 6, now it's 5 4. At this time I'm increasing, so next one it will be 4, 5, 6. So in that way, everything is going in this way. At the end, I have to see F. I have to see F. If I find F, then it will be done, because my design is tested in this way. Okay, my design is tested in this way. You can see it here. My design, I'm giving it for 6 cycles, because one cycle is 10 nanosecond. For 6 times, I'm increasing, because I'm giving up down value 1, I'm increasing, and for 6 times I have increased here. You can see it here. 0, so 1, 2, 3, 4, 5, 6. For 6 times I have increased. After that, for 3 times I have decreased. So I will decrease 3 times. I will decrease 3 times. 1, 2, 3. I have decreased, then increase. Okay, up down is the one controlling everything. So at the end of the time, when everything is done, so when everything is done here in the test bench, when everything is done, this is the test bench, by the way, do not confuse, this is a test bench. I'm giving values, up down values, so that I will see if everything is working right. So after all these things are done, at the end I will check seg value. I will check seg value. If seg value is like this, which is F, stands for F, then everything is okay, it's done. Otherwise it's failed. So test bench, you do not change any test bench here. Okay, so this is how it's done, and you will show me these values in this way. So you make minus minus and show me in this way. So I should be able to see these numbers. This is one picture that you have to take. The other picture is to show me seg values. Just press plus plus and you'll see seg values here, and show me the end one around here. You can show me this, and you will take a picture of this, and you will take a picture of the modified version. If you want it, you can take a picture of the code that you have written, or you can also submit the .v file of the file that we have, which is this one. You can submit this part. Okay, after modification, you'll submit this part. Okay, thanks for watching.